Well, hello. Welcome, everyone. And here is another AI talk, right? Yeah, sorry about that. This is actually Quarkus Unleashed. This is the only reference I will make to AI in this talk, right? I'm pretty sure a lot of you are very tired, especially because you heard about AI. And yeah, so now I make a mistake because I reference that again. But anyway, let's just take the jokes out of the side. And my name is Roberto, so thank you so much for being here. The name of the talk is actually Quarkus Unleashed. I'm working with the Quarkus team, and before we dig into this very technical session about Quarkus, I would like to do like a really quick raise of hands. So who's here using Quarkus? Excellent. Does anyone here ever wrote a Quarkus extension? Okay, just a couple. That's great. So that's going to be an excellent talk to you. Does anyone actually knows how Quarkus works internally? Okay, just a couple. Okay. Just asking these questions to see how I'm going to pace the talk, right? So I have a couple slides here because I have to explain a little bit how Quarkus works internally, because that's going to be the basis for us to learn how we build an extension and why extensions are actually a good thing in the Quarkus ecosystem, right? So yeah, so how does Quarkus actually works? So before, let's have a brief look into the past, really quick. So thinking how a traditional framework starts in the Java ecosystem, and this is usually valid for things like Spring, Wildfly, Liberty, and many of these runtimes and frameworks that we had for like 20 or 15 years ago, right? So what you do is, you just build your application, you just create your classes, whatever, and you have like a build tool, like Maven, Gradle, doesn't really matter. That generates a jar, right, or a war, fetch jar, whatever you want, and then you hand that over to the runtime, and then that's the runtime that's going to do all the work to just extract what's on the jar file. It's going to do scanning on the annotations. It's going to bootstrap thread pools, build models. It's going to do a lot of work, right? Now, one of the issues with this approach, right, and I'm not saying that's wrong, I mean, that's how we have done it for many years, is you're seeing that usually you get a lot of memory usage because you ended up loading a lot of classes. There's a lot of dynamism involved, right? So things like dynamic class loading, you have to load a lot of things to figure something out. There's a lot of reflection also involved, right? Usually to search for these annotations, to just call methods, do transactions. There's a lot of things also that happen a lot. And they perform a lot of initialization at runtime, right? So just to give a quick question as well. Who takes like 10 seconds to start the app? 20? 1 minute? Yeah, a lot, right? And that's actually before you doing any useful work, right? So a lot of that startup time is just like bootstrapping all the things needed for the app to be able to be useful and serve whatever you require for your customers, right? Now, we think that this was not really a good thing, and we tried to shift things a little bit with Quarkus, right? And what we actually wanted to do with Quarkus was to shift things a little bit around and try to move a lot of this logic and a lot of the things that happen when the application is being started up during compilation, right? So if you think about it, I'll give you an example. Imagine that you have an XML file or an application properties file, right? Usually that does not change between your build and compilation, right? So you can parse that during compilation time, and you're saving time when you're starting up the app, right? Now, if you think about it, this may not save you so much memory, so much time, but if you apply the same principle to pretty much everything that's happening on your libraries, on your runtime, then you start adding all of these savings, and in the end, you're going to have way more benefits when you're running the app with less memory and less startup time. And that's usually what we try to offer you with Quarkus. So what are the benefits when you have this build time enhancement, right? So you do the work once, not at every start, right? And especially this is very true when you're running multiple nodes on your cloud instances, right? And if you think about it, let's just say you're running like 10, 50, 100 nodes. All of these nodes are going to have to do the exact same work when they start up, right? Ideally, what you want is to them to do most of the work a single time, and then when they start, they'll just start very quickly, right? Again, a lot of the classes that you use to initialize stuff, they no longer need it, right? So you can just remove those from the runtime, and of course, less classes to load, less memory usage, right? Again, because you don't do so much work, you're gonna do less startup time, right? And a lot of the other things that we do is we try to remove a lot of dynamic proxying and the reflection, because I mean those are good. I mean these features are really, really cool, but of course they have a price to pay, right? And especially when you're now running things into the cloud where you have to pay exactly what you use in terms of memory, in terms of CPU, all of these things end up adding price to your cost of the cloud, right? So we try to reduce a lot of things over there. Now, a lot of these benefits that we have done were not only for JVM mode, right? So we wanted to also benefit things like GraalVM. Anyone here is using GraalVM or native images? Okay, a few, wonderful. And the reason why we also have to do this kind of work is because GraalVM has a couple of limitations that we're going to see in a second. Now, when we started to do all of this work, we also started to notice that these unlocked a lot of other really cool benefits, right? Things like hot reloading, right? So if, yes, as many of you already use Quarkus, you know that when you have a Quarkus application, you can change wherever class or resource files that you want, and Quarkus will automatically restart, right? And the reason why we're able to do that so well is because we have all of this work done during compilation, right? So there is no complicated things like this dynamic class loading or reflection, which those are the things that complicated the reload of classes, right? So in most cases, what you have on the application is just single Java code, which we can reload very easily. Other things like dev services, right? So as you know, if you have a database on your application, we can also start a Docker container just by inspecting the app, right? So in essence, what you have is when you're doing all of this build time work, you also end up collecting a lot of information from the app that you usually do not have until you go to runtime on a traditional framework, right? So again, that allows us to do all of these cool features that Quarkus have. Other things like continuous testing, right? Which is the feature where you just start up your test, and whenever you change your code, Quarkus is able to know which test has to execute compared to the change that you made. Another thing that's not talked enough is, in my opinion, right, and of course I'm biased, but I think when you build a Quarkus application, it's actually more safe, right? Because since we move a lot of the code from runtime to build time, many of the exceptions that you may have during runtime now become build time or compilation exceptions, right? Meaning that you're going to have a more safe environment when you're developing your app. And of course, you have unified configuration across the board. Native image. Now, I know that some of you already use native image. I'm not going to go too much in detail about this. But the things that I want to talk about this is, and maybe you're aware, maybe you don't, but the problem is with native image is a lot of the things that we are used to do in the past, they do not work on native image anymore, right? So for instance, things like dynamic class loading, they do not work, right? The reason why that doesn't work is because, I mean, you're building a native executable with a closed world assumption, right? So you cannot just go over there and load classes dynamically. That does not work. I think they're doing some work trying to make that work, but at the moment, that's not supported. Other things like reflection, right? So when you have a JVM environment, right, doesn't really matter, right? Because JVM has all the class path, there's all the classes over there. So if you do a reflection call, yeah, JVM can just go on your class path and load it, right? Now on a native image, right? Native image only includes what it needs to execute your application, right? So if you think about a reflection call, that's not like something that you can statically call, right? So it's something like a string, so it's not really safe, right? That's because when you're trying to do a reflection call, you have to do like all of these track catches, right? Because, I mean, you're just doing a string search over a method or a class, right? Which the JVM doesn't know if it's there. So in case of native image, to be able to make that work, you have to actually include manually what you need to call by reflection. Because if you don't do that, then the other way that a native image could work with reflection, it will have to include everything in the executable. And you will end up with a native image with maybe a couple of jigs. And that's not very interesting, right? So again, for dynamic proxies, it's pretty much the same situation. And the idea that we are doing with Quarkus as well is that we're going to handle all of this for you, or you're going to have to do it yourself if you're building an extension. But usually when you're building Quarkus or using Quarkus with our own extensions, we also do this to be able to build with native image. And that's something that we guarantee to you, that when you use a Quarkus app, we're also going to be able to run that on GraalVM and native image. OK, so I'm not going to lie. So I started working on Quarkus maybe 5 years ago, and before that, I was using Quarkus as a regular user. And it was a really a change on the mindset on how you think, how to develop. Not only, well, most of the apps you don't change that much, but when you work on Quarkus, you end up thinking and end up changing the way that you think on how you're going to develop either an extension or sometimes even an app, because we got used so much on how things work on the last 20 years. When something changed radically, like in this case, then it's really mind-boggling in some occasions, and then you need some time to adjust, right? So what I'm trying to say over here is trying to think about, OK, what can we move that's being executed at runtime, at build time? It's sometimes not an easy task. And it's mostly sometimes about being a creative type of work. OK, now moving a little bit to Quarkus extensions now. So an extension just contains the logic to make the library compatible with what we have described, right? Now, to make things very, very clear, every Java library that you know on the ecosystem will still work on Quarkus. So you can use it, it's fine. But the point here is these libraries may not be using all the capabilities of Quarkus, right? To give you an example, let's just say log4j. So if log4j, you have like log4j XML or log4j.properties. So, well, we usually don't support that, but just as a quick example. So Quarkus doesn't know about the library files, like log4j.xml or whatever. So if you try to change that file, Quarkus doesn't know about that file to be able to reload itself, right? So usually, for instance, an extension can be used to say, hey, please, Quarkus, here's the library. The library has these kind of resources. Now, please monitor these resources so you can reload if they are changed, right? So there's an example where you're going to need an extension. Now, Quarkus already has like a huge ecosystem of extensions. A lot of them are provided by the Quarkus team. A lot of them are already provided by the community. And of course, you can make your own. Reasons for that may involve, I don't know, maybe you have internal libraries that you don't want to expose, but you have to do it internally. Maybe you have like this new shiny library feature that you want to go out. But here, if you go to code.quarkus, you're going to see all the extensions that are already available. And we do offer like a way for you to publish your own extension over here as well. And we can look about that later. Right? Now, how do extensions actually work? So usually what you have is you have the Quarkus core, and usually everything else is an extension, right? So Hibernate has its own extension, Jackson has its own extension, Redis has its own extension. So everything is end up being an extension on Quarkus, and when you create your Quarkus app, then you just include the extension that you want, and you're done. Now, extension is usually split into two modules, right? One would be called deployment, and that's the pieces that are going to be executed during compilation time. And then there is what we call the runtime. That are the pieces that are going to be executed, of course, when you run the app. So here is like a little bit difference, right? And now you have like this different structure that you usually probably haven't seen before, unless you build an extension, right? Now, on deployment, there is a lot of things that happen, right? So there is the pieces where we analyze the app. We generate bytecode usually, basically by looking into annotations and converting stuff. I mean, and you can go really, really very creative on what you do over here. And we do some optimizations as well, right? So sometimes extensions do optimizations, sometimes they don't, sometimes they just make it in a way that they are capable of doing like the hot reloading or being able to build to native image. But you can go creative and even improve some of the things that the extension that you're writing about can do other than the library that you're integrating against, right? So an extension and the part deployment has like two simple concepts, and those are very loosely coupled, which are what we call build steps and build items, right? And in reality, if you're familiar with build tools like Maven and Gradle, those are not very different, right? So in the end up, what you have is you have these build steps that if you compare things to Maven, for instance, you can say maybe a build step is something like compile. Well, compile probably a bad example, but you get what I mean. It's kind of like a phase where things are going to be executed, and then build items are things that are being produced by the build steps, and other build steps can consume those build items, right? So in the end, what you have is you have this build step, consumes build items, you do something with them, and then you can produce new build items, and then you keep going and going until you get to the end of the build. So to give you a couple of examples, right? So let's just say a couple of the initial state build items that we have is, well, launch mode build item, which is usually saying if Quark is launching in dev mode, in prod mode, in test mode, right? And then you may have intermediate states, let's just say unremovable bin item. That means that you want to say that the bin cannot be removed from Quarkus. And usually the final build step, it's one called jar result build step, for this is the one that's going to generate the jar. And it was, in the end, just generate this resource build item, right? So the idea over here is that as an extension, you can put yourself in between the Quarkus build, and you can consume Quarkus build items, you can produce new build items, and whenever you want, other extensions can also start consuming your build items and to end up making the final assembly of Quarkus, right? So also, if you go to our documentation, you're going to see like, go to this page. So this is just a screenshot, but you'll search Quarkus build items, and you'll search all the documentation of the build items, and you can look for and say, oh, let's just say I wanted to know what are the REST endpoints that were being discovered by Quarkus. And you can consume that build item and get a list of all the REST endpoints, and maybe you can do something with that. I don't know. So my point here is build items are also shared between extensions, right? So you can consume build items by other extensions, and you can do really interesting things with those. A couple more things about extension deployments is we do offer something we call Gendex. So Gendex is an index that contains the entire scan of all the libraries that are available on the class path for Quarkus. So it's a really interesting mechanism because that allows you to do some things like, hey, Gendex, please give me the classes that contain this annotation. Or please Quarkus give me, please Gendex give me the classes that are implemented by this interface, right? So allows you to query a lot of things, and then you can be able to get a lot of this metadata, and of course you can make decisions with that. The other thing that we have is bytecode recorders. This is a really advanced concept. I'm going to see this with a couple of demos as well. But one of the things that we also do with Quarkus is we are able to record some of the objects that you produce during build time. So when you start runtime, they're already available, and we can just reconstruct the object, and we don't have to pay a lot of the costs for those objects to be created on the first place, right? That's a complex, a little bit hard to grasp, but once I do some demos, I hope that will be more clear. We also contain a lot of the GraalVM configuration. Some libraries, they don't need this, right? So all of the things that I'm talking about are optional, so you can choose what level of integration you want to add. Those are not mandatory at all, so let's just say a library does not need let's just say library as is built exactly as it needs in GraalVM, so you don't need to do all of this. But if you actually need to do something with GraalVM, then you place the code on extensions, either by substitutions or other things, right? And I also have a couple examples about this. Now, extension runtime. So this is probably a little bit more familiar, right? Because that's going to be where you're going to have your runtime code. And here is where, when your application starts, that's where the code is going to be executed. So this contains all the bytecode that you may have generated or not. So in most cases, you don't need to go and generate bytecode. But if you need, we have some libraries that make those things a little bit easier. In most cases, you don't need that. And that's where also you have like the static init and the runtime init, startup times or startup mechanisms to bootstrap the app, right? Okay, so I think we cover a little bit of the theoretical part. Let's go and do some demos, right? Because I think by looking into code, you're going to have a better understanding on how things are. And the first thing is, if you want to create a Quarkus extension, we offer an archetype. You can go it with Maven. Unfortunately, we don't have, while Quarkus, you can have a Quarkus application in Gradle. If you want to have a Quarkus extension, unfortunately, we only support Maven for now. Not sure if we're ever going to support Gradle for doing an extension, but any Gradle users? A couple. Sorry about that. We'll see if we can make that better. Okay, so does anyone know this? A few, right? So I'm a very fan of manga and Dragon Ball. So probably if you know Dragon Ball, you know that the main character Goku, he took like forever to transform, right? And usually sometimes it took like ages or like full episodes to transform to be able to send an attack, right? And so what I have over here is, and I'm going to show like a real case, but this is just like a fun case, right? So I created this library, which is called like Saiyan, right? So Goku is a Saiyan, doesn't really matter. And then he has like a method over here called Kamehameha, which is the attack that he performs, right? And in here you'll see, well, if you want to transform, it takes like, well, I have like, I'm cheating over here, but it has like a thread sleep of 10 seconds, right? Because it's going to take some time to do that. Now, this is just like a simple class, doesn't really matter. But if you go over here and I'll run this, right? Obviously, what you're going to observe is, yes, it's going to say, yeah, I'm transforming. Now you're going to wait these 10 seconds. And in the end, yeah, we're going to see, yeah, I'm done. And then it sends calls the method, and then he sends this attack, right? Now, with Quarkus, one of the things that we can do is, OK, I create an extension for this. And if I look into my deployment, you'll see that what I have is something called the processor. And now you'll see here things like build steps, right? So these are the objects, or these are the methods that you can use to do something with the library. And you have build items, right? So build item is simple POJO, nothing out of the ordinary. Usually the only thing that you want to do it with it is call it, make it final, and either extend like simple build item or multi-build item. So the difference between simple and multi is a simple build item can only be produced once, and a multiple can be produced many times. So let's just say the configuration for REST client, of course, there's only one configuration, can only be produced one time. So in that particular case, you can have like REST client build item, which extends simple build item, right? But for instance, a REST endpoint, because you can have many, then you can say REST client endpoint extends multiple build items. So that allows you also to have some granularity and to have some validation, right? Because you don't want to produce many items of a thing that can only exist one time, right? And so now here I have what I call the processor, right? And on the processor, I just annotate this with build step. So again, there is no really any, how to say it? So there is no standard here in the sense that you have to follow a particular naming structure or a particular organization, right? So usually what we do is we call it the processor because that's the thing that's going to process the things at compilation time. The method names can be wherever you want. You just have to annotate it with build step. And then here you'll just say, hey, this is going to produce something called like a library build item. And you can also produce something called an additional bean build item, right? So on my library, I'll say library.produce. I'll say library build item. And then if you look over here, let me just extract this. I'm going to create my cyan class. So that's the one that's going to be calling over here, which will take these 10 seconds, right? Then I place that into a build item. That's fine. I'll get to this in a sec. And then what you have is what we call the recorder, right? So recorder is still a method on the processor. It's still annotated with build step. But the difference is over here is that you're going to say, hey, please, Quarkus, record this object from compilation to runtime, right? And what you're going to do over here is now you have a recorder. And on the recorder, I mean, you can probably put that code over here as well. I mean, this library holder. And this is just going to contain a reference to the cyan class that I already created on my compilation time. So what's actually you're not going to see this here. I'm going to show you that later. But what Quarkus is actually going to do over here is going to look into this and say, hey, so you're telling me that you want to record this object, right, from compilation to runtime. So what it's going to do is Quarkus is going to record this. It's going to serialize. No, it's not using Java serialization. I'm going to just show you what the code is going to do. And then when Quarkus starts, it's just going to use the instance that already, well, a new instance because it's a different object, but it's not going to pay the price that we have to pay to initialize that object, right? So it's a little bit complicated. At least for me at the start, it was mind-boggling how that was being done. But let's see if I can explain this a little bit better when we look into the generated code as well. So how does this work, right? So I go over here, right? And here I have an application, doesn't really matter. I have a deployment, right? Which is over here. But let's go here to my app. So I think all of that is already built. And I'm just going to do, so that's just a MCI. It's just an alias for MVN clean install. Now you see that the system outputs that I had that were being executed when I run the library now are being executed during compilation time, right? And now, of course, if I do the jar, now Quarkus already started. And I didn't have to pay that price, right? And now I can actually have like an endpoint over here, and just I call that curl. Now you have like object completely ready, and I can just call over that, and I didn't have to pay the price of that initialization, right? So obviously, I did exaggerate this a little bit. Sorry, not that one. So obviously, I did exaggerate this a little bit with this 10, right? But this was just to show, to be able to show more properly the benefit that we have with bytecode recording. Obviously, in most libraries we're talking, yes, they take a couple of milliseconds to create the objects, right? But when you start adding all of these things up, then you start getting real benefits in the end. Now, how does this actually work? So I have here like Quarkus has like a configuration, which is called Quarkus package decompiler, right? And now you can actually go over here on my build, and you can see what Quarkus actually generated for this. So if you go here, Quarkus, runner, recorder, you're going to see something like a library, processor, right? And this was generated by Quarkus. And now you see that Quarkus here on this deploy, it created like this object. It set whatever values that object had, and then it registered that object with that method that I called over here. So now you have a completely prepared instance that you can use without having to pay that cost price, right? So that's what we call with bytecode recorder. So sometimes the concepts will be hard to grasp. It's more easy when you look into code. And again, you don't have to worry about this because you don't have to write this code. So Quarkus will automatically do that for you as long as you go over there on the processor over here and you say, hey, Quarkus, please record this object. And then Quarkus will do that for you. So there are some constraints, right, when you're recording objects. So while we don't use serialization, what actually Quarkus does is it will just call getters and setters to recreate the object, or you can just say, please, Quarkus, use this constructor to recreate the object from the other side, right? And then Quarkus will just generate the bytecode to do all of these operations. And I'm gonna give an example with a better one with the next demo. Cool. So this was to show a little bit that part. So I think we don't need that anymore. So let's close that one. Now let's gonna open this one. Does anyone know Data Faker? Okay, a few. So Data Faker is a very small library. It's a really interesting library because it allows you to generate fake data. So it has really, really crazy stuff. Let me just go over here on my app. And so I have like this resource. Basically, you have like this faker object. And now from this faker object, you can just generate names. But it has a lot of other cool things. So yeah, let me see. So you have all of these methods that you can use. And I'm not sure if you are like a Buffy fan. But if you're a Buffy fan, you can go say Buffy, and then you say like, hey, give me the characters of Buffy. And it will just generate a Buffy character. And then you have like Buffy character. Or you can say faker dot, I think there was, let's see, Chuck Norris, of course. And now you say a fact, and then you get a random Chuck Norris fact, right? So it's a really cool library. There is like a bunch of things that you can pick up from here. Let me say Big Bang Theory, right? So explore it. I use it a lot to get random data, right? The ones that I use the most is of course names. And so let's kill that one. And now I have the app over here. And I can start it up. I'm going to run it in Quarkus Dev. And yes, I have this REST endpoint. I created this faker object. And well, I can go over here and say curl plain faker. Well, let's do plain faker slash name. And now you have like random names getting executed. So nothing out of the ordinary. But I wanted to use like a real library to do an extension, right? So in this particular case over here, I'm not using a Quarkus extension. I still use the library, and that's totally fine. But let me try to do something here. So let's kill this one. And now I'm going to try to build this for native. Oops. So shouldn't take that long because it just hopefully it's going to blow up. La la. There you go, right? So now if you're going to go and look into the exception, right? Let's see. Okay, so NetDataFake is using like a random service, right? And GraalVM doesn't like that. Why doesn't like that? Because this random service that's being done with DataFake is actually being done on a static block. And one of the things that native image does is it will compile all the static blocks when you build the image, right? Meaning that it has to start the random service. But that's not what you want, right? Because you're basically starting the random service on the build box, not the runtime box, right? Because then you can pick up the native image and then execute it somewhere else, right? And you want to start the random service on your on the machine that's actually going to run the app, right? So one of the issues with this library is that if you pick it as is, while it does, of course, work on Quarkus and GraalVM mode, it does not work on native image, right? So we have to do something about it. So yes, we could use an extension for that. Now, obviously, we also want to make the experience a little bit better, right? So we can go and do a lot of cool things when we build an extension. So again, now I have my deployment folder over here, or my deployment module, and just a couple of classes. I have this called the data faker build item, which is going to take the faker object, and we're going to do something very similar with what we've done with the previous example with Saint. So I'm going to create the faker object during compilation time. I'm going to tell Quarkus to record it. And I have a processor. So one of the first things that you can do is something very simple. You have like this build step, feature build item, and you can say, hey, this is the feature that I'm implementing, right? And this is what it actually does is when you start up Quarkus, it will just output the thing over here, right? So if you want to have your extension being shown up here, that's what you've done. So nothing really out of the ordinary. So we're going to skip those two methods for now. One of the other things that I had was this additional bin build item, right? And of course, you're on Quarkus environment. We are on a CDI, ARC. So you want to be able to inject the data faker object, right? So what do you do to be able to inject that? So you create a producer, right? And I have here my producer. I say, here's a singleton. Please produce a faker. And this is just going to take a faker from a faker holder, which is the one that's going to be recorded. It doesn't really matter. But now, what this allows me to do is just with this registration, now on my app, and I go here to another resource, now I'm able to go on Quarkus and say, hey, please inject faker, right? And I don't have to create the faker object anymore. I can just do the injection point directly, right? Just with that line. Now let's see a couple of other things, right? So that's how I'm able to create a bin. That's fine. Now, one of the things that you have to do with the extension is you have to know a little about the library you're integrating. And usually, if you're building that integration, it means that most likely you're also playing with that library, right? Now, remember when I told you that when you're recording an object, you have to have either getters or setters to Quarkus to be able to reconstruct the object. So in some cases, Faker doesn't support that or doesn't give you the proper methods. So in this particular case is when you're recording an object, you can say, hey, recorded context, please register this non-default constructor, because that's what the constructor that we call is the non-default one, and then we call getters and setters. And please call this constructor and now passing these methods or these values to reconstruct the object on the other side, right? So this is another way. So usually we can do that automatically if the object that you want to record already provides the way. If it doesn't, that's okay. You can do it that way. Or we can also say, hey, please register this substitution, meaning that I have a couple of examples over here. So these fake values so let's go over here. Yeah. So these fake values that were coming from the library, they didn't have a default constructor. All the constructors were like private or whatever. And then you can create what we call a substitution, which is, hey, please, Quarkus, record these objects instead, Quarkus fake values, and now reconstruct it to the other side like this. So in this particular case, they have like an off object. So it's not a constructor that I can use on the other side. Now you can just say, hey, it's a substitution. Now please record it like this. Sorry. And when you deserialize it, please deserialize it and create it like this, right? So there is a lot of options you can use to do this, right? But yeah, so this required me to go to the library, see exactly all the objects that they were creating, and then I had to, in many cases, I could use this API to register this non-default constructor to recreate the object, or just create these substitutions to create my own objects that could be recorded and then could be unserialized from the other side. Then in the end, what you have is, the recorder calling the method faker to record that faker object and do exactly what we have done with the previous example. So this is the recording part, and this is the part that's going to save you some memory and some startup time. But again, this is not really required. I usually do this just to show you the capabilities that you can do with Quarkus. Okay, so if you look into their API, let's do something even more interesting. If you look into their API, you'll see, okay, it is getting started. So you'll see there's something here called custom providers, which means that you can create your own faker object, which can take like a YAML file, then you can populate it with some data, and then you can use that faker to just get data from random data from that YAML file and do whatever, right? So obviously what I did is on my application, I created these Manga Heroes provider, right? So it has to extend abstract provider from faker. It has like provider registration, and then you have the path, which is Manga Heroes. And if you look into Manga Heroes, well, you see there is like Goku, and you can just add a couple more. I'll add more a few later. And well, this allows you. Now you have to require some registration, right? So you have to do like this faker object, and then you have to call. So you have to do like some integration here. But yeah, I mean, I can do a couple of things better with Quarkus. And here on my processor, now you'll see I have this method called providers. So trying to expand this. There you go. And one of the things that I do with providers is I use this. Let me just extract this. So this is the index view with this. So this is the Gendex that I mentioned earlier. And now with Gendex, you can call something called get all known subclasses of abstract provider. Right? It's really cool. Right? And if you look into other APIs of Gendex, you'll see get all known implementations, get class by name, get annotations, right? And so this will give me all the things that were discovered on the Quarkus app that are abstract providers, which is this particular case, right? Which is an abstract provider, right? And now I can look and say, oh, the file should be this one, right? And this is also being done, obviously, on compile time, obviously. So I have a to-do here. So for instance, I can say, I can even now throw an error, right, on during compilation, say, hey, I cannot find the file for this provider, right? On the other, if I don't, well, I haven't done this error here, but this is something where I can put like a compilation error instead of an error that's going to happen in runtime where you cannot find the file. Now, obviously, I want to be able to reload Quarkus if I change the file, right? So what I do over here is I say, hey, Quarkus, please watch this file for hot deployment. And now I pass to the file, and now every time I change the file, Quarkus will detect the changes and will reload the file as well. And obviously, then I create a data faker provider build item because maybe someone wants to consume this and do something with the provider, right? So this was just to discover, register a couple of things, and now we're done. So if you go here to my processor again, now I have the create part, right? And create part actually consumes the data provider build item, and you can see this is actually multi-build because I can have, of course, multiple providers. And now what you're looking over here is just setting up the faker object with that data provider, blah, blah, blah. And then in the end, just creates that, and you're done. So this was just like another way or something else that can improve a little bit the situation. And you can, of course, now you can have like that data provider. You don't have to do anything out of the ordinary. And my resource book, what we only do is just, actually this one, we're just going to inject Manga Heroes. So I also create a bean out of that. And now you can call it, and then you'll get something out. So let me just roll back this one for now. So that's done. Let me just build this to remove things that were on compile. Okay. So if I run now these on Quarkus Dev, So everything's still the same. I go and call Manga Heroes. I get Goku, right? And now I can come over here on my Manga Heroes YAML, and well, let's add Naruto. And let's add Luffy as well. Now let's call that again. Now you got Luffy, right? And the reason for this, right, is because now I put on my extension to be able to hot reload when I change that file. See how fast it was as well. Right? But obviously you had to put that over there because Quarkus does not know about that file without the extension, right? Because Quarkus is just a core. So now you can see that you can do like very, very, in my opinion, very interesting things with this. So we discover providers, we register, we just put some hot deployments on that file, we created the object is being recorded, right? So you create beans for that, right? So these are the provider beans. So those are the ones that allow you to do that inject with Manga Heroes. And this is the recording part. Now the last part I want to show you is the native executable, right? So native executable, what it does is, so one of the things is, we have to call the provider by reflection. That's what Faker does, right? So in that particular case, what I'm going to do over here is, hey, iterate over all the providers that I discovered, and please register this reflective class build item, which of course is going to do is, please register all the constructors of this class to reflection, right? So that means that if I try to run native image, actually when I try to build it actually blow up first because of the random, but if it wasn't a random problem, when I actually executed the native image, it will blow up because there was no constructors that the native image could call by reflection. So now I can also come over here and register those manually like this. But that's not enough. So in that particular case, what I have here is, in this like a very advanced API, it's what we call substitutions. So this is actually a GraalVM API, and that allows you to substitute code when GraalVM is building the image. And that's what we do in many occasions to fix issues on the libraries, in that particular case on Faker, because it has that static block over here. So if you look here on this random service, here is the static variable that GraalVM does not like. Sorry? So in this particular case, what we do is, okay, let's generate a substitution. We put like a target class. So this is the class I'm going to substitute random. And now you can put like, I mean, it's a little bit complicated. I mean, depends on how you look about this, but you'll say, here's the target class. Please create an alias for this random. And now create an alias, for, not an alias, well, alias for this. And now you can actually instruct GraalVM to do a couple of things and say, hey, please recompute this value from alias, right? Meaning that when GraalVM is building, it will actually going to ignore what it was on the other class, and it will just substitute it by this one. And meaning that this will now be executed on runtime, so we remove the problem with the random. Yes, I'm also overriding substituting hash code because it's just, on that particular class, it was doing something weird. But hopefully, if I come over here, and I'm almost out of time, so hopefully let's see if I'm able to build this native image really quick. If I go over here and start and build a native image, it should be able to build just fine, just by adding those substitutions, right? So you could go to the actual library and try to talk with the developers over there and say, hey, please, this doesn't work really well on native image. You can change the code over there. But I didn't want to do that over there. Okay, so it blew up. Let me see why. So there's still a random over there. So probably, let me see. I probably have to restart everything. So let's roll back all of that. Let's kill that one. Okay. And like this. Let's hope. So I have 30 seconds. Let's see if my computer can build this in 30 seconds. Probably not. Let me see if it built the other things first. Yeah. But yeah, so these are some of the things that you have to do if you want to build for native. And hopefully already passed that part. So you see now it's building all the stuff already. So I fixed the issue with the random, and now I'm going to be able to call my app using a native Vim executable, right? So it's still not done. Let's just, so since I'm out of time, let's just do some things here. So if you want to go to some of this stuff, you can go to these websites. And I'd like to thank you, all of you, to be here on this presentation.